specialize in a particular domain. And so I like to ask our guests, like, what would you consider your area of specialization? What are you a specialist in?
Oh, what am I a specialist in? I think it might be thinking like an engineer. Prior to joining AWS, I've spent 14 years as a disciplined petroleum engineer. So I worked on rigs, in Canada, Russia, Middle East. And so and then also moving into other roles where I've had to do a lot of surveillance on, oil field equipment, whether it's like reservoirs, fields, and, and it kind of took me into different roles, and it's kind of shaped the way I think about things. So I come to a customer more as an engineer than a technologist. So I think that's kind of like my specialty or something different. I'm coming at things from uh someone who's trying to sit in the customer's shoes. Before I even think about the cloud and the stack and the algorithms, right? I always think about the business problem first. And I think, yeah, I always like feeling stupid as well. And I love asking stupid questions to the customer. And yeah, I love feeling stupid. But yeah, I think, I think though that those years of discipline engineering is always, it's got me to focus on certain things where I think if you were an SA or just someone that just works on algorithms or back-end systems or front end, you might have a different view of the world, right? So yeah. So yeah, I think yeah.
I think that's a really interesting thing, like what petroleum engineer, and not necessarily a software engineer. When I think, in the context of the world that we live in, we think when you say engineer, we think software engineer. But you're saying you have this totally unique and different engineering perspective that you can bring to
Yeah,
cloud technology or the work
yeah.
that we're
So
doing.
yeah, so when I was younger, I loved robotics, so I did electrical engineering. Uh, and I was like, oh yeah, I wanna go and build some robots. So I ended up working, in different automation roles, building like PLC systems, SCADA systems, working on really large projects for, various industrial control where like you go into a lumber mill, setting up like control systems to cut the 2x4, right? And they're spinning, they're going at like 1800 feet per second, right? And that kind of engineer, like designing those systems, and then maybe like, for something that mixes concrete at Lafarge, those are the type of projects I started off with. And then I joined the oil field and I started working on like, I learned about reservoir engineering, geology, and then starting to work up the chain. So it's like, oh, compressors, pump systems, all sorts of like physical things. And then going into like things where, you're planning budgets, you're looking at logistics, working. And yeah. So I was a lead production engineer for a few years. And so I had to take on like various responsibilities. And I think that's kind of influenced the way I think about things. Right. And so, yeah, I even like, yeah. I also spent some time as a petroleum engineer working with McKinsey, trying to cut down our operational budget and those things. And, the thing they drilled into me was, what is the value of the thing that you're trying to implement? Is it actually going to affect the unit operating cost? Is it actually going to make a difference, right? And then those are the questions that kind of bleed into, when I talk to a customer. I'm um listening for whether listening to the questions of the customer and trying to understand whether it's a real true business need, or is it just maybe some curiosity or excitement, right? Is Yeah, for us as a prototyping team, we can kind of go deep, right? But should we go deep on that problem? Is it a true business problem, right? And and in my experience, if we actually solve the business problem for the customer, that's what, and we kind of decompose the business problem into a set of algorithms, a set of like things into a workload that we can run on AWS, that's kind of what makes it sticky, right? So if it's like, yeah, we can solve many problems, but should we? Right? Will it? Yeah.
Yeah, you can very quickly start chasing your tail on certain problems, right? And you're like, well, and then you go down all these different rabbit holes. And so having good discernment, being humble in what you don't know, but always being looking at what's going to drive the biggest impact, I think is a really good perspective to have. So Charles, like what so you're working at AWS on the specialist prototyping team. I think it's a really cool background that you have. What have you been working on lately that's got you really jacked?
Man, so something interesting. We've been working on market intelligence um, for I think since the end of 2024, right? And so initially we were just looking at RAG-based systems where we had some automotive customers that went, oh, look, I need to reduce this manual effort where I want to know every car spec of all the manufacturers, and I'm going to upload these PDFs, and I just want to make sure whether one of these 400 specs exists, for a new car coming out. Because um, my customers were really interested in the value added features that they would put into the next production run of a car. So, they go through and then they might add a feature, right? And so that feature should be cheap to implement and drive consumption, right? So initially we're like, okay, let's just orchestrate this in a very simple way. We're gonna
Okay, so
set yeah, go ahead.
Charles, I just want to make sure that I understand. So we're talking about generative AI systems. We're talking about retrieval
Absolutely.
augmented generation, which is like still a very. Sometimes I feel like the stuff that we're working on moves so quickly that it can prematurely feel out of date. But retrieval augmented generation is still very much a necessary and efficient mechanism and pattern, despite the fact that some of us are moving on to these like new and like a multi-agentic orchestration or whatever the next frontier is, and that we can get caught in this trap as prototype folks to like
Yeah.
the chasing the newest thing.
Oh,
Retrieval
yeah.
augmented generation. A huge portion of our customers are still implementing those systems. And you're saying what you've been able to do is kind of like index all of these different car specs into
Yeah.
some sort of, what kind of index was it? Is it like a knowledge base, or what are you using under the hood there?
Yeah, so it's quite simple, right? So that was one of the earlier RAG kind of prototypes we built. So we would take PDFs, convert them to Markdown, and then chunk them and store them in a vector store, right? And then part of it as well, I think, is underappreciated is the embedding model that you choose, the actual nuts and bolts of the retriever. You need to check that the embedding model actually understands the concepts or the words used in the text, right? So if you're looking, because these retriever models might be tuned for a certain domain, they might have been trained on English literature, right? Or they might have been trained on Reddit, right? It doesn't it so you need to test the performance in term, like just like you would a search engine. So you would test things like retrieval and perform and precision at K. So you want to see like the results coming back, that are relevant. Um, and so
Yeah,
that
that's
was one
interesting.
of the
For the retrieval augmented, for the embeddings part of it, for the indexing, I've always been kind of lazy in that regard, because it's like Amazon can, or AWS can sometimes make it a little too easy just to accept the defaults and say, yeah, I'll accept the default like embeddings model, the default chunking strategy, the default thing. And for the most part, that's been really efficient and works for most of the use cases. But you're saying maybe when it gets to some of these deeper technical domains, those embeddings are going to start to really matter.
there are no guarantees that you're going to get the chunk retrieved, even if it exists. So you should
Mm.
test if you're going into something very specific like financial or medical. You just really want you want to make sure that you write that test first, right? And it's just a simple test. You might have 100 chunks. You just want to make sure that, and you can add in like distractor chunks as well. You just want to make sure like that the first part of the RAG system, which is the retrieval, which is the search engine bit, actually works, right? Um, and in my experiments, I actually found the older systems to work well as well. So something like a sparse index, like BM25, works really well. So that's the older system that that powers the search engines. They still work really well. So even if you were to have a free text index on the text chunks, or yeah, basically you just chunk it and then just have a free text search, that works as well, which is really surprising. And then you find agents these days, they actually grep, they actually look for keywords,
Yeah.
and
I see a lot of
yeah,
greps in
you see
the
it
work
coming
that
back,
way.
right? So yeah. So I think in terms of like rich RAG, those concepts, having using those embeddings as clusters, uh, and tying things together as concepts and topics makes it more interesting. And so interesting story. So after that prototype, the customer loved it. So basically, we were able to pull out 400 specs with a combination of two agents. So there's the initial RAG agent that validates the spec, and then there's a quality testing agent. So it basically verifies. It's a more powerful LLM. It basically verifies that that verifies the RAG result. And in human testing, we were able to validate that. It gave us an accuracy of like 97%. And we're like, this is better than a human, right? And our customer, they were able to like save weeks. They had teams of people poring over these PDFs to understand whether one car had that matrix of specs. So for $1.10, which is what it costs to run that pipeline, it actually brought in real value. And I was like, okay, this is curious. This is really cool. And yeah, I needed to do that project to prove to myself that RAG was good. Yeah, and then internally, I started to get requests from a few internal teams where they had a different problem, right? They had a different problem where they had tens of thousands to 100,000 kind of customer tickets, and they just wanted to understand the theme of what's happening. They, RAG is great when you have like a point query, or like if you have a very pointed question and you want a very specific answer. RAG is not going to tell you if you ask a general question like, so what are the top 5 problems right now in my that my customers are complaining about? It's not going to tell you, right? And that's because RAG, if like there are some implementations of RAG where you ask a question, you retrieve a chunk, and maybe based on that chunk, it's like a pinball, right? It's like a pinball machine. And so, curiously, I landed on some really cool algorithms like BERT topic and fast topic. And what was interesting is if you can take that embedding and you can kind of cluster them, they kind of form natural topics, don't they? Right? So you're able to consume say, hundreds of thousands of documents, and basically you can imagine them as like a million loose leaf pages just on your desk, right? But if you had a really fast algorithm, I'm talking about a minute to run 100,000 documents through. If you had a fast algorithm to first order those pages in some kind of topic space, right? So it just puts together natural topics. And then once you have like a set of topics, you can sample from them. So you can maybe look at 10 of those pages and go, this is what the heading of this topic is. You could run sentiment analysis over each of them to understand what the customer sentiment is. You can run other tools that pull out just You can run what are they called? Um, Token classifiers. So you can pull out entities that you want to extract. So locations, product features, and other things, right? And you can even summarize the whole topic. And so what you have is this aspect-based sentiment analysis engine that's very efficient, and it'll run within minutes. And all of a sudden, what you have is a table of contents and an index for all of the topics. So what we started to do is have an agent, instead of directly going to the raw data, right to the pages, it would query the table of contents first, which is what we would do as humans, right? So I was like, okay, so if I could summarize everything, and I'm like, yeah, that's cool. We started using that in our internal systems. So that double dip type of approach, super interesting, right?
Yeah, I think I understand what you're saying. Like, so I mean, it seems like there seems like there's so much to varying aspects of a end-to-end like generative AI system, and there's no like real like one thing. There's different approaches that make sense. And what I hear you saying is like it made sense first to classify the information in some logical way, and you did that through the index, and then you wrote to kind of like this meta information or a table of contents that you could first query to understand what are the contents of the index before you just
That's
are
right.
querying the index directly. And that optimized or opened up use cases that maybe were hard for the agent to do before just by querying straight to the index.
And yeah, and one of the problems that my friends and my customers were telling me about was they were just trying to push to create this metadata. They were just trying to push all the raw documents to an LLM, which could take weeks to months for a corpus because it's quite slow. And so you need a different approach, which is a little bit more optimal, where you just use a really fast embedding, where actually I started using static embeddings, which don't require attention, and they just go bang. So those static embeddings are good enough that you could run hundreds of thousands of them in minutes on your Mac, right? You can embed them, and then you can start um, running either BERT topic, fast topic, getting clusters. And then once you have those clusters, it's easy. You can just sample from those clusters and do what you need. Um, and so that was interesting, and that's a great summary of information. So when like I tested it with some internal systems, so it's like, what are the top 10 problems that Bedrock is facing? And I was like, wow, this is really insightful, right? And I could see it adding value. Um, and so one of the logical extensions to that that I'm working with now is I'm going back to building knowledge graphs. So initially, I had some interesting research or prototypes where we would build knowledge graphs to try and understand depositional environments for exploration. So for mining exploration here. So we scrape the entire, like, whatever relevant pages from the U.S. Geological Survey, and basically they went, okay, here are all these different deposition types, and here are the tracers, here are the things that or here are the signatures, right? And so I had a customer that said, look, I want to look at a press release and understand whether the things that what are the implications of that press release. And then go, okay, so we found helium. Okay, helium indicates that you've got this and this, and they're probably in this location. That's the deposit they're working with. Maybe I buy them out. Maybe they're worth, they're an acquisition target. So actually that was one of our first prototypes with LLMs. And we fine-tuned GPT-J a long time ago. That was the first open source LLM model that was available. And so we basically got GPT-J to do structured extraction from like raw text. So it would generate graph triplets. So from these geological documents. And so we created this huge mother graph. and and the challenge was it was really hard to query, and you had to be really precise with your graph SQL, and the agents at that time, like the LLMs, couldn't query it properly. They didn't have that background information. And now, what's interesting is, I'm working on some projects with some mathematicians, and initially when they first approached us, I was like, oh, this is jiggery pokery. Like, what do you mean hypergraphs? What do you mean high category theory? What is all this rubbish, right? I think it's all high level BS. Um, but
Just a lot of
but
hand
actually,
waving and and cool words.
absolutely, absolutely. I thought, okay, I couldn't make these graphs work, and so actually, before I went to the mathematicians, I worked with some drug discovery labs, and we tried to basically mine PubMed, OpenProt, UniProt, and all of these other like biological data sets to kind of come up with trying to discover a new drug target, right? And so part of like a big part of that is mining the literature, creating these structures and these sentences and these fact tables that we could join together. So they might be two disparate sets of facts that haven't been connected together, right? And so that was the aim. Um, and and basically, I ended up with a graph again. I ended up with a tiny knowledge graph at the end, and I didn't know how to connect the pieces together, right? I didn't. I, it
Well,
was
well,
it
a
was
graph
it
would
was
seem to make sense, right? Because you're trying to build like meaning from the relationship of the information, not just index the like some ordered information. You're trying to derive semantic meaning from the relationship. So like if you're going to take these different data sets and try to say, okay, where are the relationships here? It makes sense that you would end somewhere on a graph, like a graph
yeah,
based
and
system.
so
But when you say
absolutely.
hypergraph, I have no idea what you're talking about.
Yeah. So I had to learn what that was. So, when you look at a normal graph, like a normal graph connects two nodes, right? And there's only a single edge that can connect two nodes. So say if that edge was an action in the middle. So say it could be some event like a shortage in chips or something, right? In reality, that edge affects more than just two nodes, right? That edge might affect multiple entities, multiple companies. So it's not sufficient. So for you to represent that, all of it, you would have to have like multiple edges, and it gets really complex. So the simple idea, make that edge another node. So the edge types are simple. So you basically make that edge a node, and then that's what creates a hyper edge. So then the node connects. It becomes like uh, this kind of wheel, this hub with
No,
spokes.
I think I'm picking up what you're saying. Maybe you can correct me if I'm wrong, because this is the first time I'm really hearing about this as a topic, and maybe my fumbling through it will be helpful for people listening to it themselves. But like, so you're saying you have these two nodes. It's connected by an edge. That edge is some relationship definition or semantic a definition of the relationship of those two nodes. But you're saying that connection can become a node itself. So now you're introducing some like dimensionality in the relationship that is not just from node to node. And then if you that can be presumably like in layers deep,
Exactly.
and
So
so now you
so
kind of
so
you have
yeah.
this much more complex.
So the edge becomes a node that's in the center of multiple things. So then when you do your queries, it's really the results connect everything that's possibly connected to it. And the results from even simple queries designed with hypergraphs is hypergraphs just a graph. It's just I had to reason with this myself, but the queries are richer, and agents can do a lot with those raw queries. And so here's the interesting path that the mathematicians have shown me. So So they kept going on to me about ontologies. We need to define the ontologies for what we work on. And the ontology is just basically the type of nodes that you can have, right? Or the type of entities that you have, and then also the relationships, right? And I was like, yeah, okay, this makes sense. Let's try and prove it out in this application. And so what's interesting is that becomes a set of like logical statements. So this event causes that event to happen. So if you can imagine in the application I was building, we had events as the center or as the hub of uh, of these little graphlets. So the hub could affect multiple countries, multiple industries, right? And then what we had was like this hub affecting another hub. And so it became like a chain of events. And so what I'm starting to understand is if the ontology or the set of entities and the relations that you have, um, basically when you define that, that means you define a finite set of structures. So this could be like loops. If you could just imagine like in a graph or a graphlet, like part of the graph having a loop or a chain or a tree, right? So if you imagine those things and you go, wait a minute, well that means I can write richer graph queries now to look at the structure. So I could look at consistency of like different perspectives. So maybe automotive manufacturers said that they have these specs here, but when I look at the market signals, the customers aren't talking about them. They're not raving about them, right? So I can look at things like consistency. I could look at cycles of of what people are talking about and whether they're just a flash in the pan or they're longer term cycles, right? It's really interesting, and I'm like, okay, so if we can start to unpack, like if the ontology will kind of lead us to a set of structures, right, that we can look for, then we have that on one side. And on the other side, I started mining the common crawl. And so I mean, prior to this project with the mathematicians, I was like, okay, um, I never really got into the common crawl, and I realized that the common crawl sits on AWS. It's hosted in US East 1. And what you
What,
can do is,
what define to me the common crawl. I don't know that I've heard that term before.
so the common crawl is basically it's an organization that indexes the whole of the internet once a month with, and they
Okay.
respect robots.txt. So basically there's an HTML backup or copy of or snapshot of every site on the internet on S3, and it gets updated once a month or once every 2 months. Can you imagine?
No, I mean, I
Yeah,
think
yeah.
theoretically, sure, it makes sense that is possible. But I'm trying to going into that bucket and taking a would probably blow my mind.
Yeah, so what I started, so the idea was okay, so working with these mathematicians, they were like, oh, we're just hand cherry picking some documents, for research, and you basically take those documents, try and create this hypergraph that you query, right, with a bunch of math, with a bunch of SQL and math, right? And then basically you prove out certain shapes, and those, if you find those shapes, you're like, yeah, I found gold, like I found a real uh, you know, real relationship connecting this to that, right? So that's the high level, right? I still coming to grips of what it means, but their challenge was they weren't able to get enough data, right? So they were just cherry picking a few things, and I was trying different type of like search engines, Firecrawl, Tantivy, right? They only give you a small subset, and they may not even be relevant, right? And so I thought, why don't we just mine the whole internet? It's just sitting there, right to mine. Why don't we just
Yeah,
do
why
that?
not?
Why not, right? It's like I work at AWS. Why can't I mine it? And we've got this open data set sitting right there. And so I went, okay. I was like, give me the ontology. So give me the set of like um entities you want to extract, and give me the set of like relationships that you want to extract. Yeah. So with the common crawl, what's interesting is it has an index. So it has an index file, and then it has like all of these Parquet files with all of the websites there, right? With all of the HTML. And so the first challenge is, defining the domains you wanna scrape if they're there. So that would be like Al Jazeera, CNN, Fox, and then the paths that you want to get from it. So basically, you can load it in Athena, and you get, and what those queries will give you is give you a pointer to the byte offsets of the actual HTML sitting in those Parquet files. So then you have like, so I have so for that prototype I had maybe a set of close to 2 million, right, that I needed to parse or to address or deal with.
Create these pointers for.
Yeah, I had like 2 million pointers. I'm like, okay, now what do I do? I'm like, okay, so I'm just going to have like a fleet of GPU workers, right? They're just going to like spin up like 100 of them, and I can push these to a queue. I can push all of these to a queue and just have the workers just work on them and just start. So each worker just takes the HTML, converts it to text, and then from there I use like just an LLM with a structured grammar. This is important. So it gives me out a JSON object, right? A JSON object with the event type, the actors, and I have like hints. So which I'm going to talk about later, but you need hints to normalize entities. So just imagine now we're getting out like these raw edges that I want to kind of compose together later, right? And so I have these edges coming um, out of these news articles, and they could be multiple edges from a news article. No problem. I'm just dumping them all into into JSON in on S3, right? And so yeah, and so what some of the properties that the edge needs to have is they need to have a location, and a timestamp, and the entities involved, right, and the head and the tail. Right. And then I was like, oh, how do I stitch this together? And so maybe the first pass that I ran was you need to normalize the entities and the head and the tail. So you might have like the US mentioned, in the raw extraction, it might say US, it might say USA, you might say the United States, right? And so you need to normalize those entities first, so they all, they might have multiple aliases, but they're really referring to the same entity. So I created like this table, a really fast table, to kind of look up and normalize that so that the head and the tail of these raw edges are the same. And so the other thing you want to do is you want to cluster them over time and space. So basically, you might have CNN, NBC, all of them reporting on the same event, right? And so you have to kind of cluster these edges together. And basically, these edge clusters form one hyper edge of that graph, right? So we clean it up. And so I started, I started building hyper edges for this graph, and I put it together. Then, oh yeah, it started to be really interesting, and I tried it on a few domains. So the minute you have like this hyper graph, it's a little bit noisy, right? So it's going to be a little bit corrupted. But then remember what I was talking about with those ontologies and the types of shapes based on the ontology, right? So you have a set of like logical statements, and there are only a finite set of logical structures that can come out of those. So then you have this kind of dirty hypergraph, right? And so I was running some algorithms. Like basically, I was getting Kiro and Claude Code to kind of help me stitch those together to find the distance between those two. And so I started looking into like program synthesis, where I run different algorithms to kind of clean up this hypergraph more and find these structures that have a close match. And so I defined a few like cost functions, and those were interesting. And so yeah, so on one side you have a template, and then you try and match the dirty data in the graph to the template. And
Yeah, that's what I
and
was about
yeah,
to
that's
say.
what I'm
So
having.
you're trying to conform the hypergraph to the ontology so that the agent or whatever you're using to query against this, or whatever question you try to ask of this data, has a
Yeah.
clear
Yeah.
roadmap to the data.
Exactly. Because you respect the fact that this data is dirty, right? And it's never going to be clean. But if you kind of see a pattern in it, you want to pull that out. And so these like I basically got the agent to run a search. So these coding agents basically went, okay, I'm going to run these algorithms to kind of pattern match this and that. And yeah, some of the things that in the cost function that I had were not don't leave too many orphans. So you want to try and minimize the data you're living out. You're also trying to maximize the consistency of those two things. And so I'm just
Tell
playing
us,
with it
like,
now.
this is all seems deeply like, um, I think you are deep into the science and engineering of how these models and these algorithms need to work. What are the most efficient data structures in order? What's the practical implication? Say you achieve these sort of like these these really robust and efficient and deeply nuanced hypergraphs. What does that enable me to do?
Yeah, so it's kind of, there's this phrase where if you know the past, then you can kind of predict the future. And so what you want to do is you want to try and look at the shapes that happened in the past, whether they're loops, cycles, paths or trees, and you kind of want to project them into future. So yeah, so looking at things like consistency in between like a product specification and the market fit, what customers are actually saying could help you design the next features for a killer product, right? Looking
Yeah.
how looking
Whether
yeah,
or not
yeah,
you're trying to determine what to put on the next model of car that you're building, and you're
absolutely.
trying to
Yeah.
evaluate the historical, like, what did people actually buy? Why did they buy it? What's
Why did it
the
yeah,
relationship between? Okay,
and
because I
then
don't want to just put out something that's not going to get bought.
yeah.
That
Yeah,
makes
yeah,
a lot of sense.
and then there are things like what causes the biggest shock to a company? Is it regulation? Is it supply chain? Is it the consumer activity? And then like doing a search, you can go, okay, this regulation caused me to cause all of these companies to spend X
These
billion
cascading
dollars.
effects. Yeah.
You look at cascades, um, and then you can look at company strategies as well. You can go, okay, Tesla might have done these things in this order, right? And then for their next acquisition, it's most probable that they're going to the same cycle will appear again, right? So you're trying to understand behavior as well, um, and then yeah, I think so. What did we
Well,
talked about?
I can see this applied in so many different domains. Like, we're talking about maybe a more retail oriented, like consumer behavior
Yep, yep,
domain. But, you mentioned pharmaceuticals. You can start to think about this in a healthcare space. Like, what are the impacts of certain medications on populations, or what are the impacts of certain health data and trends that you can start to suss out, and
yeah.
what are the implications? Like, I can see, like, maybe it's not a direct like correlation, but you can kind of see how this type of ontological road mapping of hypergraphs
Hypergraph.
becomes
Yeah, yeah, yeah. Yeah.
a hypergraph becomes a model for trends in multiple domains.
Absolutely. And the thing is, the cool part about it to me is that it moves away from like semantic reasoning that you'll have in the LLM. The LLM, it doesn't use its logic. Basically, these outputs are SQL queries with math. So they're like direct logical statements that come out of the query, right? With a bound of error, right? So they're not,
Right, right,
you're not
right, because
depending
the
on.
semantics are embedded into the data, the representation of the data, not the reasoning ability of the model.
Right. Yeah. So you're basically coming out with, the reasoning that comes out of your SQL statements and the way you query this thing, or the structures you look for, are are basically based on the ontology and the set of like uh entities and the relationships, right? So it's purely math, right? And it's provable. And yeah, you really don't have to worry that your LLM changed. The LLMs can do a great interpretation, but to me, you go, yeah, I need, and it goes back to like the facts that I was collecting for the medical research. The researchers wanted fact scoring. You're like, how good is this fact? Like, how how relevant is it? How does it apply to my premise, right? How much of it
Then you start
is.
to really start to do you start to value data a little bit differently. It's not so much that, like early, I think in my journey on around Gen AI, there's the question was like, hey, I've been collecting this data, but mostly as a means of operations, right? Like I have to report on this. I'm trying to see my profit. I'm trying to do some sort of like reporting mechanism. But then how do I take all this data that I've collected and get value out of it? So it starts to answer the question, what's the value of the data? Well, I mean, if you can kind of have this self-evident, like ontological roadmap to your data, then the value starts to become a little bit clearer, and you can start to put agents against it to say, "Well, here's the value of
Yeah,
your data. It tells you this."
yeah, and then the agents act as routers, not like as the logic itself, right? And so there are
Yeah, yeah,
multiple, yeah. And so there are multiple layers to this pie, and I think all of them are useful. So you still want RAG for your pointed questions, for your answer,
looking up
pointed
an
answers.
index of unstructured data,
Absolutely,
regs.
absolutely.
Yeah, you still
Yeah,
still
you
need it.
still. Then the concept of clustering and extracting the aspects from it and doing sentiment analysis makes sense when you want to look at groups of things. You want to compress the information from a million documents to like 10 10 lines, right? So you want to get the so what out of it. And then that next level, I think, is the ontology. It unlocks some interesting aspects. And I think maybe going into the math is it's kind of been like a tar pit for me. I was like, oh, looking at category theory and algebra. I'm like, no, wait, look. What's really cool is that these agents now they understand the math, and it's more like you have to ask the right questions. Like, can you find me this structure with some math, right? And so I've been relying heavily on like program synthesis from the coding agents. Like, write me the right SQL to find this structure. And yeah,
Yeah, that's kind of a cool. I think you're alluding to something that I have been feeling more and more lately as I start to build out some of these prototypes, or I put my builder hat on for part of my day, and I say, hey, maybe my skill set is shifting not just from can I develop the code? Do I know the right functions or syntax or frameworks or whatever it is? But can I ask the right question? And how do I get better at asking the right question, um, so that I can achieve the outcome that I'm hoping to achieve? And I think that skill set is going to be really it's going to open up a lot of potential for people who might have been saying, "Hey, I'm not technical, but I know what I'm trying to achieve." Right?
Absolutely. And I think the paradigm difference is like between being like going from like quantum physics and chemistry, which is that one extreme, to
Right.
being a baker. A baker doesn't give a shit about the
Yeah.
chemical impacts. The baker cares about whether the cookies taste good or not. They don't
Right.
care,
Right.
right? Right. And
Yeah.
so me personally, I'm moving to becoming more of the baker, where I don't really care, if it adds value, that's great, and I'll use whatever tool that I have at my disposal to make that secret cookie, right? To make those recipes for my customers, right?
Yeah.
Right. And so
Well, the irony,
yeah, yeah.
Charles, is that despite the fact that you claim that you're becoming a baker, what you've just described to me is much more deeper than is the cookie tasting good. And actually, this is a question I have, Charles. Like how did maybe you have this like kind of unique background. I kind of have a similar story. I think there's a lot of builders that I run into or folks that are working with some of this stuff that have unique backgrounds, and they're like, hey, I didn't always that's like I didn't set off in my career to be a mathematician defining like hypergraph structures and data sets. But I was doing this other thing. I just was curious. How did you where did your learning path begin for some of these deeper, more complex mathematical aspects of what you're
Ooh.
doing?
Oh, the more complex math, I I don't know. I think the more complex math started over the last couple of years, I guess. Just exploring, and yeah, I've just done applied maths, not pure mathematics. And so, look, I'm as an engineer, I understand how Fourier transforms work. Why don't do I really need to go back and prove that the Fourier transform works or not? No, it just works, right? And so if I can get these, like the way I think of it is like, yeah, I can go to death. Like I can go to town on trying to prove the how something is built versus discover something that works. And if yeah, it's just like yeah, I'm trying not to get into that sticky tar pit of death where everyone's like reasoning with each other at very high levels, and you're like, yeah, no, does the cookie taste good? That's all I care about, right? And
Yeah,
and
yeah,
if it
yeah.
and yeah, if it works for my customers, I don't care. Like I don't care what theory we use, as long as there's a clear path and a repeatable process. I went into the math and I went, oh man, this is crazy in terms of what started me off in data science. Oh, maybe 2010, 2011, I had to manage these fields where I had a lot of telemetry coming in,
Hmm.
and I wanted to understand like, okay, how is my reservoir performing? How are my pumps working? And I was working with some very large time series databases. You'd have them there. They're historians that sit on SCADA systems that just record point measurements. And that's where I started playing with feature engineering. I'm like, okay, maybe I can put a first order, second order equation on this because that's what a pump curve looks like. That's what a reservoir inflow looks like, right? And that's kind of what got me passionate about data science. I was like working on this time series data, converting these raw time series into features. That's what got me started. And I was like, okay, I have to revisit all the linear algebra, probability theory, right? I had them on my ebook readers,
Yeah,
but yeah, that's what got me into data science before it was called data science, I guess.
yeah,
Um,
yeah.
yeah, but
Well, that's
yeah, but
funny
then
that you that you mentioned that because you're like, so it sounds like to me like just through some of your exposure to the data and you're kind of engineering curiosity kind of led you to ask questions about that what you were seeing in the data, and you said, well, and you just sort of applied that curiosity, and then that just sent you deeper down the rabbit hole.
oh yeah, it's crazy, right? It's like if you plot data the right way and then you see a curve out of like data, then there's a natural function sitting there. There's a true something there, right? Under there, yeah. So that's kind of what got me hooked, right? And then yeah, I joining Amazon. I think I had a colleague. He was like, "Oh yeah, you're gonna love Amazon." I'm like, "Wait a minute, it's I'm a data scientist, but I don't feel like I'm good enough to join Amazon." He's like, "Oh, just join as a petroleum engineer, and then you'll join the energy BU. You'll and yeah, to my surprise, the recruiter was like, "Oh, just apply as a data scientist." I'm like, I don't know. I don't think I could do this. Anyway, passed the test, passed the interviews, and I'm like, oh wait, I'm a data scientist at AWS now, working at professional services. And yeah, I've been feeling stupid. I like feeling stupid, and I like, yeah, yeah. And
Yeah, you
now with
mentioned
these
that. Like, feel like
mathematicians,
being humbled in what you don't know is definitionally how you grow, because like you have to step outside of what you're comfortable with in order. I mean, that I have my father-in-law always say that's the definition of growth, is stepping outside of your comfort zone, because otherwise you don't actually grow. And I like that too, because that is a humbling perspective, because it makes that what you described as, I think, what people would call the imposter syndrome, right? Like that. And I think almost every Amazonian that I have run into is at some point in their career felt like experienced some level of imposter syndrome. But
yeah,
if you are curious and you work through that, you come out the other side with like becoming a specialist, becoming an expert, becoming somebody who's willing to ask questions of the data, or pursue certain paths, and yeah, eventually some of it starts to stick.
some of it starts to stick, and you go, okay, after these 8 years, I finally go back to, okay, ontologies, and like this is kind of, you end up revisiting things that you were looking at before that never made sense. And you go,
Yeah,
okay, that's right on the money. Maybe generative AI and the coding abilities for these agents now can really help me discover some patterns, some new things now, right? And it's definitely an exciting, I should put an exciting time to be alive, and an exciting field to be working in.
I totally agree. I've been saying a lot lately, like it's never been more exciting to be a builder. I have experienced this a lot, like the world that has been opened up to me as just somebody who's curious by nature. I was same way, not necessarily like, I was the type of kid that wanted to, I was always really good at taking the thing apart, but not so great at putting it back together. And I'm still the kind of that kid, like where I like to crack open, see how it works, but don't ask me to put it back together. But now, through the help of agents and generative AI and some of the tooling that's available to me now, uh, I don't have to worry so much about how to put it back together. I'll let the agent do that, but I can still ask the question, how does this thing work? And that's a really cool place to be in. Uh, I was just I was just thinking about this the other day. One of the things that I've been particularly interested in is how just LLM evaluations has really been an area of interest for me. Just how do we know that these things are incrementally getting better and producing the desired? How do we baseline? How do we measure? And then how do we do that? I've been looking at research, kind of breaking down what's available today, what are the tools and systems and patterns that are available today that people are using, and then where's that bleeding edge of research that's saying, hey, this is where we're trending. And I'm running into a lot of research papers that start to break down like cognitive sciences. How does the brain work? What are some of the cognitive behavioral uh, uh, patterns that we can apply to some of these systems? Because the brain's obviously very efficient at synthesizing information. And I'm like, man, I'm reading some of these research papers, and I'm like, I have no idea what these guys are talking about, or girls are talking about. Like, this makes no sense to me. But what I've been doing is I've been throwing those into an index, or into an LLM, and I'm saying, explain this to me like I'm in fifth grade. And then it breaks it down for me. I'm like, oh, okay, so this big scary technical term really just means this. And I think, Charles,
Yeah,
what you were
yeah, yeah.
describing to me, how you were describing to me hypergraphs and ontological mapping and all of these things, and I'm like, I'm just using that same sort of learning approach of like, okay, if I was a fifth grader trying to understand this, oh, it's not so complicated. These are just really big words.
Yeah, yeah, absolutely. And like, interesting with the rules, right? I think there was an internal team that that basically wanted to grade documents, or grade content coming out. And they were like, how good is this? How good is this rubric, right? How good is this rule, right? That I'm using to test things. And one of the interesting patterns that we started using was using LLMs to kind of break the rule. So most like say if it's a document quality system going in, you expect that most users are going to put in like nice sounding documents to kind of,
Yeah.
they're going to be
Create a
putting in
bias in
genuine
the
content.
system that say, look, it's working.
Yeah, yeah, exactly, right. And everyone's happy. Oh, the rules work, and we're like, no, wait. What if you put in an agent that's trying to break it and skirt the rule, right? So put in like, pleasant, like convincing enough sounding language to kind of red team the system. And so based on the rules, and it was interesting, right? When we were testing it, those systems actually the scores just dropped off. And he went, look, you need to fix these rules. The rules themselves need to be fixed, right? And and the rules themselves are prompts that are used with LLMs, right? And so basically, this how you specify it, like a word, a bag of words or some examples could improve the performance. So
Yeah,
yeah,
that's cool.
yeah, yeah.
That's cool. Some of the different patterns you get to start to play with, and angles you get to attack it. Charles, like this is all like really cool stuff, and I'm excited to see what you're building and how you apply it to customer problems. I think there's going to be uh, a lot of exciting new frontiers to explore, and it's cool to be on a team that gets to do some of that. Um, One of the things I like to ask
Absolutely.
people is like, if you're just getting started in your career, because you are how many years into your career, have this engineering experience. You're not you've been kind of, you're at this point in your career where you're really kind of cruising with some of this stuff. But if I'm new and I'm coming out of college, or I'm like just getting into this stuff, what advice would you have for people that maybe just getting started with some of this stuff?
Oh, just think about what you're trying to achieve and think about the tests. So it goes back to my first manager at Amazon. He was like, write the test first. Just write the test about what, for what you're trying to do. Just some test driven development. So yeah, I'm first to say I'm the worst software engineer on my team. Like I write the worst code. I used to write the worst code, and I'm not ashamed of it, right? I'm coming as it from an engineer, like I'll write the equation, I'll write that 2 lines of MATLAB code that I'm happy with. And I don't care. I don't care about the rest, right?
And
And so
MATLAB.
yeah. Oh yeah, yeah. And so my boss is like, write the test first, learn how to think critically. So yeah, for people getting started, just look at where the value is. If look at what you're trying to solve, understand if there's value in it, if you're trying to solve a business problem, but maybe just understand what the test could be. Right? How do you test something? Because I think what's going to happen is all of us are just going to lean into generative AI, LLMs as tutors, as co-authors, as peers, right? At some point, right? It's going to happen. We're all going to lean into it, and we just need to have that critical learn a little bit of critical thinking, right? Because you could almost build anything with LLMs now, right? Uh, it's do you the question is, do you want to build something that's useful, and whether the thing that you built is actually working, right? So learn to think
If I had
critically
to
and
put
write the
on my
test.
Amazonian hat, of which I'm actually wearing an Amazonian hat, I would describe that as the working backwards process generally. And that is something that we talk about a lot here at AWS, is how do we work backwards from customer problems, but first understanding what that problem is and then working backwards to solve it. Very high level. I think that applies in your career development. Where do you want to go? How do you work backwards from that? And that takes a little bit of foresight, and it takes a little bit of maturity, and it takes a little bit of like, deep thinking and reflection. But if you can do that, and the better you get at doing that, the better the outcome will be.
It's like it's a different paradigm, right? To being a worker, instead of like people you get instead of the customer telling you what to do, you put on the customer's hat and you go, okay, I'm running this business today. What am I actually looking at? What are my problems, right? If you walk a mile in their shoes, I think you will start to get a different perspective, right? And to be successful, I think not everyone's going to tell you what the problem is, right? So it's probably a good idea to, just do some exploring, do some research before you meet with a customer. Like now the generative AI tools are amazing, right? Last year, before I meet any customer, I spent 2 weeks on Perplexity just trying to understand like the background. I do a lot of research, and my team does a lot of research before we even talk to them, right? So when we come in and have those conversations, those terms that they use, they actually would mean more than if we were to come in cold, right? So prepare, be curious, yeah, and yeah, just simple things, right? And simple things that that make you professional, right? Versus the technical skills. I think those will make the difference to your trajectory.
Yeah, Charles, I love that. I think this is all really good stuff, and I think that this is a good place to maybe wrap this up. And I think what I'd love to do is have you back on and actually peek behind the curtain a little bit and actually see some of the stuff that you're talking about in action. I think we did a really great job talking about it today, and I think it's sparked some new and creative thinking on my end. Hopefully, it does for the people that hear this too. But I would love to then next time pull up your screen and say, okay, what does this look like in action, and then how do we build on top of this, and what are some of the open-ended questions that maybe we're pursuing? I think that'd be a lot of fun. So if you'd like to come back on, we'll talk some more.
Love to. I would love to. And there are a lot of people on my team just like me, with curiosities and passions in different areas. So yeah, feel free to reach out to them as well.
Yeah, hopefully I get to talk to them. That's kind of my goal here.
Yeah, yeah.
Hey, Charles,
And some of the cool, go ahead.
good. No, what was that?
Oh, I haven't even touched on some of the cool fun RL stuff. We actually put in an RL agent to brew beer at Heineken. That happened in 2023. That happened like a long time ago. And so, what one of the cool uses for LLMs is we use them as world models. And so we basically trained MinGPT. So we took in all this tabular information of like measurements, set points, and efficiency from a process. So they're all like time series measurements, and we basically tokenize them in specific spaces. So we create a custom vocabulary for the LM, trained it, and then the organic chemist said, wow, this simulator is really good, and we can use it to optimize. And we had people at Heineken. Actually, there was a Heineken reInvent presentation that was the secret sauce behind it. But actually, it also gets used for staff planning at Amazon. But that was the initial thing that got us into building LLMs. Actually, it was RL. And so this was in like 2023 where we were training these models, because doing RL, which were those, when you talked about agents, the agents were RL agents playing games or like optimizing systems, optimizing HVAC and stuff. But yeah, we could talk about that next time. Is very interesting. And that's what kind of led my team to go into generative AI just by accident, building LLMs, fine tuning them, or like basically building them from scratch for very specific domains.
Well, it certainly seems inevitable now that that is the eminent domain of technology that we are all having to quickly become experts in whatever domain that you're coming from. So yeah, I'd love to come on and talk about that. That'd be great.
Yeah, yeah, yeah. I think Chen and Yin from my team, they've been really deep in the weeds of training multimodal LLMs for the last 2 years. They've been
I'm
trying
talking.
to extend.
I have a plan to talk to Chen and Yen. We are hoping to talk at the TechCon summit later this month. But
And
if we don't get a chance to talk there, we're certainly bring them on here and chat about. I had a brief introduction to Chen and some of the work that he's doing with training agents, trans
yeah, and then
agents.
and then and then we have Nick on our team who's a gun. He was a gun at like looking at um, getting, at multi-agent orchestration, ensuring like the sandboxes work, all of that technology that stitches these platforms together he's worth talking to as well. And I was hoping to have him on this call, but I think we have enough content that you could probably just have and different angles from what we're tackling, right? So I usually work with Nick. He builds a platform for me in a front end, and I look at how things
Yeah,
glue
I'm
together.
noticing that as a pattern of this team where there often is sort of like this. Uh, I see that same similar pairing with Ben and Patrick. Right, Patrick is kind of off writing this front end, but Ben is off doing these kind of little science experiments, and there's like this
Yeah,
really nice flywheel like glue that kind of binds them together.
yeah, absolutely, now there's so much demand for coming and doing these prototypes, and it's more of a matter of us picking and choosing or having some big bets and going, okay, look, this year we're gonna do something on like robotics and world models and physical AI, and then maybe we'll do something on deep research, which yeah. Yeah, and so it's probably good for teams to just make bets on areas and just go deep and just enjoy it, because I
I'm trying
think,
to. I'm learning how to do that. Like this is like it's a way of doing business that makes sense, but is still the mechanics of it are still relatively new to me. Right, just based on the team that I'm coming from, and now being on the prototyping team and learning how it operates uh, in that kind of big bet mindset is something that I'm learning how to do. Trying to be humble and learn from you all who have been here a little bit longer, but it's exciting, and I'm just trying to figure out how to navigate it.
yeah, and one exciting project that I'm hoping for towards the middle of the year is, basically we've got a TV broadcaster with all this long form old content. They're sitting on this mine of content, and they want to make short content out of it. And I'm like, oh, now that's interesting to me. It's like maybe, we could track different features, zoom in and slow, like instead of making the video, linear, you could like, speed up certain things, slow things down, and then just have like a 10-second highlight of something to
Yeah.
to
Hey, if that becomes a reality, pull me in on that because I would. That is something I am actively. You know what it is? It is for me. It is the art of storytelling, and how do
yeah,
we like?
yeah,
So how do you tell a story given a broad amount of content? That's something I want to do with this podcast and the conversation we're having now. Like we kind of went into different little vignettes and different things, but there's a story that we can weave through some of the stuff that we talked about. How do we do
yeah.
that? Maybe a little bit more agentically is a really interesting
Yeah,
problem.
and how to do it quickly, right? So, basically you need to see when the content's kind of changing topic, like just have those flags. And then
Yeah,
within those flags, just try and compress it. So it's like, have you ever watched the movie summaries on YouTube where someone will have just a quick walkthrough of a movie? It's like, now this guy's doing this, and there's like a narration on top.
sure,
Like
sure.
that's yeah, I'm like, yeah, that's kind of what I want. And kind of like, understanding like the different like the change points in your video that you've recorded or the other videos that you have, right? And understanding what's in there, and then just maybe stitching it together to make it very attractive and fun.
Yeah, I think there too. Okay, so there's an optimistic side of me that's like that is a really cool way to explore storytelling in a new kind of way. Then there's the pessimistic side of me that's like that's also a really cool way to manipulate information in a really negative way. So like if we're being just like conscious
Mhm.
of the intent and baking in guardrails that achieve the right intent, I think I'm going to favor the optimistic side of me.
Yeah, I think from my side, it's I guess it depends on the impact, right? If it's like sports
Right.
reels and highlights and just making things just super
Yeah,
attractive,
sure.
wanting just maybe you're like chopping something, you're it's a cooking show and you're like, oh wait. I know this customer is interested in cooking, and then all of a sudden Amazon ad shows up on the side. It's like, oh, let's buy this knife. So and so has got this book, like immediate like ad placement. I think that'll be cool. And then also like the short form content. Yeah, I would like those are things that I
Also,
think.
it's interesting you say that because we just launched on AWS On Air in a recent episode. We interviewed AWS Elemental, and they launched a feature called AWS Elemental Inference. And what it's doing is
Mm,
it is during live encoding, it is running inference models on the content to create kind of like what you were suggesting, meta information that can then be used in a very specific way in real time. I mean, real time, there's like still an encoding delay. I think it's just a few seconds, but for that inference to occur. But then what can you do with that meta information? Well, it just the tip of the spear is like, well, obviously there's obvious things you can do. You can clip highlights that, of a sports thing. Hey, some significant event happened, but then you can start to predict preferences a little bit more in real time. Hey, if you're watching something and you start to wane interest or you lose something else, look, a highlight comes on that knows that you're interested in, you can auto format video to different formats and contents, and so live sports can start to compete in more modern consumption patterns. Uh, the thing that was really broke the thing open to me is like this idea of when certain things occur in live content, you can trigger other things to occur.
mm.
Man, if you take just like that basic premise and think about all the different event driven live content things you can do, oh man, the possibilities are endless.
And it doesn't have to be live, right? A lot of customers a lot of consumers would just stream things. You could do this totally offline. You could like totally prepare like those event chains based on the customers like click stream or understand what their persona is. And then you could just pre-bake it and go, yeah, I'm gonna I'm gonna give you things that you find useful, interesting, that. And then on the other side, it's like a win-win. Like the company's selling value-adding products to these customers, right? Yeah,
That's it.
yeah.
That's it.
Ah, man.
That's the exciting part of this is what I'm talking about. It's never been more exciting to be a builder at AWS, and the possibilities just seem endless. And I've always taken a very optimistic perspective of the future, just because I get to see a glimpse of what some of those possibilities are.
And
I'm not
yeah,
I'm not of the nihilistic kind of persuasion.
and like looking at things like OpenClaw, if you follow them,
Yeah.
that's
How can
crazy,
you
right?
not? It's been yeah.
Mm, and you're just looking at some of the feature lists, and you go, I want that. I want to talk to this thing. I don't want to jump on a console. I just want to give an agent a task, and I don't even want to talk about them. Just go make your decisions, go do something, right? Tell me what you did. Don't like, I don't want to talk about what's
I'll be honest
possible.
with you. I've been trying to find time. I've got a MacBook. A what are they what is it called, a Mac, the desktop MacBook, the MacBook
Oh,
whatever, just sitting in the closet because I all my work is done on a company issued laptop. Now there's no way in heck that OpenClaw is going to ever be allowed on a Amazon company laptop, but I've really compelled to take that MacBook out and get OpenClaw up and running and seeing what's possible.
yeah. And then maybe have a team of like those agents, like workers just doing stuff. And then you're just looking at a dashboard. You're like, oh, what's so and so working on? And that whole
Dude,
concept of a
you know how
heart.
many books I've wanted to write that I haven't written because I just like I'm like, okay, maybe this OpenClaw can write the book for me. We could just sort of chat about it throughout the day or throughout the week, and then at
Yeah,
the end of the week, I've
on
got a
WhatsApp.
published
Yeah.
book. Yeah, exactly.
Yeah, exactly. Or on WhatsApp, you're like, yeah, okay, what are you doing? Where are you at right now? Okay, is that thing built? And it's like it just frees you, and you're like more like a manager. But the thing that blew me away, like it was something simple, but it was like the heartbeat. Like, have you heard of the heartbeat in
Mm-mm,
OpenClaw? So
mm-mm.
it's a trigger basically, and it's got a prompt. So basically, it's just a little watchdog, like a little timer that goes on, but it triggers the agent to look at its memory and what it's doing. So there's two things that can kind of trigger the agents to start working. One is a command from the user, and the other thing is its own heartbeat. It just wakes up and it goes, "Hey, oh, where did I leave off?" Right? And that simple concept, I was like, "Wow, that's what's going to make this thing autonomous, right? It just keeps waking up and just figures out what to do." Um, and then there's also some really cool memory add-ons. So I guess if it's got like a heartbeat kind of, instruction and some kind of memory just triggering, it could just really be curious, right? So I love that pattern of
That is a really interesting thing, but my intuition would be towards alignment. How do I align that curiosity to mine?
mm,
Right? Like what, so that when it does wake up and it's curious, it serves a human
I think
endeavor.
that yeah, I think that's where that memory part comes in, right? It's very like I think a lot of the things I've been hearing about OpenClaw, especially from the creator, was that it's like it started to understand what he wanted. It started to remind him about certain events that he was interested in, right? It was just kind of this
So that you
mind
saying
that
that would maybe kind of organically occurring just through interaction and its own persistent
yeah,
memory.
yeah, I
Oh,
think so.
dude.
That'd be interesting, right? So if you gave it
Hold
memory
on, man.
and you
Hold
you
on to your seat.
yeah, and then basically this thing is just the cost of obviously the tokens, but I would love a team of independent kind of prototypers that went and research for me to build something, right? And go, oh, where you at? Where you guys at? And you're like, okay, oh, that's cool. That's where you are in your research. That's very cool. How about
Well,
so it's like,
where I've been curious in that kind of like token limitation, computational limitation, is there a way to, we're seeing a lot more in, at least from my perspective, in the trend of local LLMs, right? Or SLMs, or like quantization, or the ability to run hyper specialized, small, parameter, smaller parameter SLMs locally. Could OpenClaw one manage the fine tuning and orchestration of a hyper, the actual tuning element of a SLM so that it becomes specialized? Then in that specialization, orchestrate the agent to achieve these different tasks. So you have this localized computational like requirement, kind of answers the cost and token, maybe some of
uh,
the cost. I mean, there's still
I
going to be a
think so.
token limit computation to live in it.
Yeah, absolutely. I think it's more like a switch. So it'll route between a really expensive model, and then it'll go, okay, expensive model, let me help me generate this SFT, this synthetic fine tuning data set, right?
Yeah,
Uh,
distillation, right? It'll manage the orchestration of
yeah, yeah,
distillation
yeah.
using a
Just
teacher,
create me a
a really
synthetic,
complex teacher. Yeah,
yeah, yeah, create me this synthetic data set, and I'll train a fine tuning model. I'll look at how well it does, but then these small models are really good at very specific skills. So if the agent, it would kind of like start in, maybe initially you'd have a large budget going towards the Bedrock and the models we have there, but then slowly over time it would shift over to its own small models, right? Yeah, for
yeah,
very
yeah, yeah. Right.
specific tasks, right?
You kind of front
And
load
then
the
maybe,
the costs in distillation, but then the ongoing operational cost it kind of tails off.
yeah, and then all of these skills, like these models, these SF, these fine-tuned models would just go to Hugging Face or something as a skill,
Right.
right?
Yeah,
And then
skill.
it's just
Yeah,
like,
yeah, yeah, yeah.
then it's just like a free marketplace for, like,
Man,
it'd be very interesting. It'd be very interesting,
it's,
right? And I
if
think the
only I can find the
ontologies,
time to work on that.
huh? You just need to find the right customers. I
There
think
it
I
is.
think one of the cool parts of having big bets and having like an area that you want to explore is that because you've got so many incoming things. I think when you just go and stake your claim to a certain idea, you'll find energy there, and you'll find like customers will come to you that are interested in doing that. And we do a free prototype, is and we try and learn and explore and see see where that leads, right? And
Yeah,
yeah,
I love it.
yeah, but yeah, I'm really excited to see where this open cloud project goes, and in terms of like the features that that I haven't thought about that would be useful in my own uh work, right? I would love a team of researchers, right? Like just a Isengard team. Just go, okay, where are you guys at? Yeah, what are you doing? Can you? I'm preparing to meet these customers next week. Can you just do some background research? Tell me what they're interested in, and like what do I need to prepare for? Give me a slide deck, right? Give me some PowerPoint, um
Well,
and
and even now, it's hard to truly predict like the implication, right? Like it's hard to truly predict what the new possibilities tomorrow will bring.
yeah, yeah,
Yeah,
but
not to get too like meta or philosophical, but like they're so like we have this very like it seems like we have this very there is a there is a horizon that we can only see, but that horizon expands each time we kind of come to the table
yeah,
and think about it.
absolutely. If we solve like agentic memory and alignment, and then just have these automated systems that like I think we'll get close. We'll get to a close approximation of what we want, right? And I think with some problems, we don't know the exact specs, but if we do like 10 experiments, we go, that's exactly what we don't want. Yeah, we want that, right? Running these experiments they're fairly cheap now, right? We can do 100 experiments in the time that we take to actually try and define a spec now, right? The writing of the code has become cheap. It's more like the definition of the spec is expensive now. It used to be the other way, right? Where we go and go to our Jira boards every day and go, what do we what are we working on today? And that was from a paradigm where code and code development took a long time. But I think agentic AI just like flatten that. Code development's quick, but it's actually the definition and deciding what you want. That's the expensive part, right? And
Yeah.
yeah, yeah, it's interesting. It's interesting.
That's an interesting paradigm, and it's going to be interesting to see how the application of that paradigm in the new the new world that we're building.
Yeah, it's definitely a crazy new world, man.
Hey Charles, hey, thanks for coming on. I should probably get going. This has been a really good chat. I'm excited to clip this up and see what gold is in this conversation. And I will follow up with you and Nick to see if we want to maybe do another shot at maybe a group conversation. And I'll shoot you some content on broadcast so that you have so you can kind of see like how I'm approaching the actual production part of it.
Oh, go for it. Yeah, feel free. You have my permission to to cut it up as much as you want, and feel free, please, to reach out to my team who I feel are just much smarter and move faster than me. You're probably talking to the dumbest person on the teams. Feel free.
All right. Well, I appreciate it, Charles. Have a good week.
Yeah, yeah. See you, Todd.
Hey, everybody. Thanks for watching, and a very special thanks to our guests for joining. Hey, if you want to stay in the know on what specialists at AWS are doing, make sure you grab a Builder ID if you haven't already, and join our space on Builder Center, where we'll be posting almost all of our content exclusively. We'll also have show announcements on X, LinkedIn, and YouTube, and we'd love to hear what you think and what you're working on. Until then, I'm Farmer Todd, and I'll see you out in the field.